And welcome to pre-chapter 1, section 6 for college algebra, the rectangular coordinate system and graphs. So we're going to plot points in the Cartesian plane and talk about the distance and midpoint formulas. So recall that the Cartesian coordinate system is what you're used to, with the x-axis being horizontal and the y-axis being vertical. So some important things to recall is that all of our coordinates are x-coordinate first and the y-coordinate. The origin is 0, 0. So let's just call that origin 0, 0. Most important spot. We have any x-intercept is a 0. So for example, anywhere along the axis, for the sake of argument, let's call it right there, a 0. We call it the x-intercept because it falls along the x-axis. Also, more importantly, the y value is a 0 at the x-intercept because it has no vertical. Inversely, the y-intercept is 0b, so something like this would be 0b. That is on the y-axis. And also with that, every y-intercept has an x-coordinate of 0. Otherwise, we can plot some points from there. So for example, A being 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. That would be A right there. B being negative 2, 4. 1, 2, 1, 2, 3, 4 would be our B. Over 2 down. Oh, sorry, that's negative 2. Negative 4. 1, 2, 1, 2, 3, 4 would be our B. Here we have C, which is negative 3, negative 2. 1, 2, 3, 1, 2 would be our C. And D being 2, negative 4. 1, 2, 1, 2, 3, 4. And then you'll see these labels of Q1, Q2, Q3, Q4. Those are called quadrants. So that is quadrants. Quadrants with root base of quad, meaning 4, just different sections to line these up. You'll notice that in quadrant 1, we had coordinate A. We had both positive values. So quadrant 1 are always positive, positive. Quadrant 2, which we had coordinate B, was negative positives. Those are negative values, positive values. Quadrant 3 had coordinate C. That was negative, negative. And then quadrant 4 was positive, negative. And then, of course, along the axes, we have zeros, which have no polarity. So those axes really divide the quadrants and don't technically fall on them. Some other things you might see are what's called a scatter plot. A scatter plot could be on the Cartesian plane, which we can do with our calculators, but often so a collection of data. So for example, height in inches by age. So if we do height by age, we know that, for example, when people are younger, especially by months, so probably children, when they're younger, they tend to be a little shorter because they eventually will grow to be bigger. That being said, sometimes younger people are taller, so you get these higher collection of datas where sometimes these are lower. But in general, this kind of concept would sort of trend upward. Now, we cannot construct a line to represent all that data, but you could see some sort of correlation. And we're going to talk about that later. That is what's called a line of best fit or a regression line. We're not going to delve too deep into it in this chapter, but it could be coming along in the future. Basically, what that tells us is give us an approximate model for the data, because obviously we can't construct a line that is through all these random coordinates. And it also tells us just how closely our data would be centered. So for example, this one doesn't look super connected because we have some values really above the line and some values pretty far below the line. Last but not least, let's talk about the midpoint and distance formula. Quickly, midpoint, you just average the individual coordinates. The x and y's are completely separate. So if I were to do this for this, I would get 5 plus 11 divided by 2. 5 plus 11 is 16, divided by 2 gives me 8. And then I would do negative 2 plus 3 divided by 2. Negative 2 plus 3 would be positive 1 divided by 2 is 0.5. So the midpoint of this coordinate would be 8, 0.5. Distance formula, we get the distance equals the square root of delta x squared plus delta y squared, delta just being change in, so you can also conceptually see it as x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And the thing that the distance formula is technically speaking, it's an application of the Pythagorean theorem. So let's say I have two coordinates. I have P1 right here, which is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So P1 is 6, 4. And P2 is 1, 2, 2, 1. Well, conceptually speaking, I can draw this into a right triangle because the x coordinates and y coordinates are perpendicular, and I can count off the length of this side. So 1, 2, 3, 4. This has a side length of 4, and this 1, 2, 3 has a side length of 3. Well, Pythagorean theorem says a squared plus b squared equals c squared, and we can agree that the distance from P2 to P1 is just the length of this side of the triangle known as the hypotenuse. So here we could do 3 squared plus 4 squared has to equal d squared. So I could find 3 squared is 9, 4 squared is 16, that's 25, and then square root, we all agree that d would equal a distance of 5. Well, conceptually speaking, all we did was count the distance of the x values in this direction, 2 to 6, and then vertically the difference in y values, 1 to 4. So if we look at just A and B, all I did for A was 4 minus 1 for 3. All I did for B was 6 minus 2, or B equals 4. If I were to write them in terms of value of the Pythagorean theorem, that would be 3 squared plus 4 squared equals d squared, and we want to get d by itself, so square root. So d equals the square root of 3 squared plus 4 squared. That's what we did, right? Well, again, this 3 was our change in x values. And this b, or the 4, is our change in y values. That's where this formula comes from. So if I didn't draw a picture and I just knew 2, 1, 6, 4, and I labeled them as x1, y1, x2, y2, and followed the formula as written, I would still get the same values. And in fact, I'd follow the same process. So square root of 6 minus 2 squared plus 4 minus 1 squared. Or I guess flipped, but the order doesn't really matter. 6 minus 2 is 4. 4 squared would be 16. 4 minus 1 is 3. 3 squared is 9. And I follow the exact same process. The distance formula just means I don't have to draw out a physical triangle, but the whole process stays the same. Thank you for listening, and I hope you have a wonderful day.